do you recall from level 1 that there are 4 types of currency swaps? What are the 4 kinds of currency swaps? First of all, let's refresh our memory. What is a currency swap? Okay, let's take this a simple form. So let's say that I want to borrow dollars and you want to borrow euro. Okay, so and let's say that for simplicity, the exchange rate is, I know this is not true, but let's say $1 is currently equal to 2 euros. Okay, so what will we do up front? We will exchange notional principal. So if I borrow $100, so I'm borrowing in dollars. Okay, so $100, and how many euros will you borrow? So you will borrow from me, given this exchange rate at the start of the transaction, you will borrow 200 euro. And then if I have borrowed $100, I will pay interest in dollars and you will pay interest in euro. Okay. Now the 4 kinds of swaps, currency swaps, one type can be that the interest in dollars is fixed, so some fixed rate, and this can happen, say, on an annual basis over 5 years. So there will be a settlement date which can be, say, annual, and there will be a whole tenor of the swap, which is 5 years in my simplistic example. So fixed would mean upfront we will fix what rate I pay in dollars and what rate you pay in euro. And what else? I could pay a floating rate in dollars and you pay a fixed rate in euros, or I can pay a fixed rate in dollars, you pay a floating rate, and what's the final possibility? A float and float. Okay, so these are the different options. Now into the exciting world of pricing and valuation, and I'm going to make you do this. This is simply taking what we just learned, or what we should have learned, and applying this over here. Consider a 1-year currency swap with semi-annual payments. The 2 currencies are US dollar and the euro. The exchange rate is 0.75 at the start of the transaction. The term structure of interest rates for LIBOR and Euribor are given here. Does this look familiar? It should, because this is the example we just did. So all the dollar related stuff is already done. These were the rates we used in our earlier example. It's the Euribor rates that are obviously different. Does everybody know what Euribor means? So just like, so LIBOR is to dollar as Euribor is to euro. All right. So determine the fixed rate in euros and express it in annualized terms. Okay. Note the LIBOR rates are the same as in example 4, which we just did, in which we found that the fixed payment was this. So we calculated the C, which is the fixed payment for dollars based on these rates. What you need to do now is use that same method to come up with the fixed rate for euro given these rates. Okay, so that's what you need to do. Okay, so let's use the same procedure. So your C is 1 minus Z2 divided by Z1 plus Z2. And these Z's are discount factors. So when you take your Euribor, what are the Z's? So 0, 180, 360. So the 180-day rate is 6%. So what is Z1? So 1 over 1 plus 0.06 over 2, which is equal to 0.9709. And what is Z1? This should be, Z2 is equal to 1 over 1 plus 0.066, so into whatever, 360 over 360, since that's 1 year out, and that is equal to 0.9381. All right, so what is the C value, the fixed coupon that we pay here and here? 1 minus Z2, which is 1 minus 0.9381 divided by 0.9709 plus 0.9381, and this should give you 0.0324. So what is this saying? This is saying that the party that borrows euro is making this payment per dollar of euro. Does that make sense? So for every dollar of euro borrowed, this counterparty is going to pay 0.03. So for every euro borrowed, this party is going to pay 0.0324 euros on a 6-month basis. Okay, so that is the, so is this the fixed rate in euros? So if we have a fixed currency swap, what is the 6-month rate paid by the counterparty that borrowed dollars? So for every dollar borrowed, the dollar party is paying 0.0392 and the euro party is paying 0.0324. Does it make sense that the euro party is paying less? It makes sense because the euro rates are lower in this example. What do you think will happen in the next part of this question? So what sort of a currency swap was this? The one we just did? Fixed. Okay. So now multiple things are happening here. 90 days later, the term structure has changed. Does this look familiar on the LIBOR side? It should, because we've already done this. This is the change in LIBOR that we saw earlier, and Euribor has also changed. Rates have come down. And what else? You can't get past level 2 without being constantly hit with currency rates. What was the initial currency rate, do you recall? It was 0.75. The new exchange rate is $0.7 for 1 euro. Okay. So determine the market value of swaps to pay dollars and receive euros. Okay, so if you got into a swap on day 0, what was the value of the swap on day 0? The value of the swap is 0. Okay, what is the price of the swap? The price of the swap is the fixed rate. So for a currency swap, you would express the fixed rate in dollars and the fixed rate in euro. Now, 90 days later, we have some value, and we need to figure out for whom. Consider all 4 swaps that are covered in the reading. Assume a notional principal of 20 million and the $20 million and an appropriate amount for euros. Note that the LIBOR rates are the same as in example 4, in which we found that the present value of fixed payments plus $1 notional principal was this, and the present value for floating payments was, so the floating payments which we did in blue earlier, the present value was 1.0180. So this is given. Now let's do part 1, or one part of this, which is fixed, and then the rest you will do for homework. If you can figure out the first part, the rest will just follow. Okay, so let's do this. How will we figure out the value? 90 days into this, so let's just draw this out. Okay, so 0, 180, 360. We are now at day 90. So in example 4, what did we figure out? We figured out that the present value of fixed payments, so at this point, the present value of fixed payments plus the $1 hypothetical amount, so this PV for dollars was how much? 1.0231. Okay, now for euro, let's do euro in blue. For the euro, what is the present value of fixed payments over here? So for, let's take notional principal of €1. So assume notional principal is equal to just euro 1. So for euro 1, do you recall coming up with your C over here and here? Remember fixed. What was the euro's C? 0.0324. And this was also 0.0324 plus €1. Now what is the present value for euros over here? How will you do that? Have we come up with these present value factors before? So you, not for euro. Okay, so you come up with the present value factors for euro. Okay, that should be the same procedure that you've done before. So do that. Okay, this discount factor from here to here should be 0.9864. So that is based on this 90-day rate for 1/4 of a year. So the present value will be this discount factor multiplied by the C, 0.0324, and the other discount factor, which is from here to here, that number is 0.9569. 0.9569. How do we get this? This is based on what rate? So this number would be based on 1 over 1 plus 0.06 multiplied by 270 over 360, since this length is 270. So this factor is 0.9569. This is multiplied by what? 1.0324. When you add these up, the sum of this and this is the present value for $1 of notional principal of euro, which is 1.0199. So do you get this? At this point, the present value of your euro payments, assuming $1 assuming €1 is this. Is everybody with me on this number? Yeah, so the $1 notional principal, that's where I used 1.0324. So the coupon payment was 0.324 plus the €1 notional principal, that's where this number is coming from. So 1.0199 represents for €1 notional principal, what is the money here? Now, come back to the beginning when this currency swap happened. What was the exchange rate at the start? So the exchange rate was $0.75 for €1. And if a swap, if we borrowed $1, that means the counterparty borrowed how many euro? Okay, remember, the amount of euro borrowed needs to be based on the exchange rate at time 0. Okay, so the counterparty borrowed how many euro? So it would be 1 over 0.75, which is 1.33 euro. So we borrowed $1 and the counterparty borrowed 1.33, because the two need to be equivalent based on the exchange rate when the swap was initiated. Is everybody with that? So the notional principal remember with the currency swap, there are two notional principals for each currency. So the dollar notional principal is what? $1, and the euro notional principal is 1.33. Okay, so these are our notional principal amounts. Now, at this point, at time equal to 90, how do we figure out the value of the swap? The way you can think of it is, let's say that we have a pay fixed, receive fixed swap, and what's the new rate? The new exchange rate is 0.7. Do you think the new exchange rate will come into play? The new exchange rate will come into play. And again, just a quick refresher from your, all the study that you've done with exchange rates. What's the base currency here? The base currency is the euro. When this quoted amount goes down, so that means the base currency has weakened. So the euro has weakened. The euro was, 1 euro was for 0.75, now it is for 0.1. So we are going to figure out the value of a pay fixed and receive fixed. So in dollar terms, how much are we paying? So the present value, so the dollar, remember, is in red, so I'm going to actually put that back in red. So how much money are we paying in dollars? It's the present value of the dollar amount. So that is minus 1.0231. So if we are paying dollars, we are paying this present value amount. And what are we receiving? We are receiving how much? We are receiving this amount of euro. But this was the amount of euro based on 1 euro, right? So this whole calculation that we did, this was based on 1 euro notional principal. So let me go back in blue for euro. Okay, so euro is in blue. Okay, so clearly this will come into play. So for 1 euro, $1 is in 1 euro notional principal, we have this is the present value. But our swap is how many euro? 1.33. So we need to multiply by this number by 1.33. So 1.33 into 1.0199. Now is this number in euros or in dollars? The red is in euros or dollars? We are taking a dollar perspective. So now should we not convert this euro into dollars? Because you can't add dollars and euros, right? You need to add dollars and dollars. Okay, so we are taking a dollar perspective. The red is dollar, the blue is euro. So how do you convert the euro into dollar? It's really basic, but by now it might seem complicated. Okay, so you have euros here. How do you convert euros to dollars? Using the exchange rate. Which exchange rate do you use? The current exchange rate or the old exchange rate? The current exchange rate. So this many euros is equal to how many dollars? So you multiply this by, so this is $0.7 per euro. If you remember your physics days, your teacher told you to keep all the units, because when the units cancel out, then you know you're doing it right. So that's what I like to do with currency. Okay, the euros cancel out. So now when we multiply by 0.7, do we have a number in euros or dollars? Okay, so now we have dollars and dollars. So you multiply this out, and then you will have the value in dollars. So minus 1.0231, which is in dollars, plus this is the present value of your euro payments that have been converted into dollars at the current exchange rate of 0.7. You do this and you get a answer of 0.0712. Okay. Now, clearly, if you've understood this thoroughly, you're a genius. But if you are normal, then what is going to happen is you have enough in your brain to go back and spend some time on this. When you spend time on this and do the other three scenarios, what are the other three scenarios? Fixed, float, float, fixed, float, float. Okay, and all use the same principle. By the time you are done with float, you know, you will probably know how to do this. Okay.